Hello. Today we're going to be reviewing transformations of linear functions. So yesterday we explored what this number out in front does, what the number inside with the x does, and what the number at the end does. So the number out in front, this is your vertical stretch. So we're going to say this is a vertical stretch of 3, meaning my graph should get 3 times as tall as it is right now. This number inside with the x is going to be moving it left and right, but it's going to do the opposite of what you think it should. So the plus, it's actually going to move your graph left 1. This plus 2 at the end, that is going to be moving your graph up and down. So our graph is going to be moved up 2. So we're going to go ahead and graph these transformations. When you graph these transformations, you want to start with your left and right, then your stretch, and then your up and down. So in order, normally you have a f of x plus h plus k. When you graph them, you're going to do h, then a, then k. That's your hack, okay, on how to graph them, right? H, A, K. Go and hack. So we're going to go ahead and graph left 1 first. So we're going to take our graph and move the points left 1. So this is what our graph would look like, oops, except I moved 2. So let's make sure it's only 1. So this is what your graph would look like if it was just left 1. Then what we're going to do is we're going to take and do our stretch of 3. So if it's on the x-axis, we don't move that one. But anything else, we're going to take the height and we're going to triple it. So it gets 3 times as tall. So my new height then should be 6. Again, I'm taking this number, my y value, and I'm tripling it. So my new height is 6. So this is our graph moved left 1 with a vertical stretch of 3. And our last thing is then moving this up 2. So this would be our new graph then. So this one in the purple. So let's go ahead and take a look at another one here. Our transformations, the number out in front, this is negative. That is going to reflect over the x-axis, aka it's going to flip it over, okay? The next one here, this x minus 4 here, you're going to be moving your graph right 4. So we're going to do this in the H-A-K order. So we're going to start by moving everything right 4. So 1, 2, 3, 4. And 1, 2, 3, 4. So this is our first graph, moving everything right 4. And now we're going to flip it over the x-axis. So I'm going to take my distance between the x-axis and this, and I'm just going to flip it up the other way. So this point, instead of being 1 below, ends up being 1 above. So this gets flipped over. This next one, instead of being 7 below, it's going to end up being 7 above. So this point gets moved up here. And these connecting here, this is my new function. That's where my new graph would be. So now we're going to do a quick recap of all of the different transformations. So let's take a look at this. You have A, H, and K. A is going to do a couple of different things here. So it's going to stretch and compress, and it's going to flip things over. So if A is greater than 1, this, for example, is saying if A is like 4 out in front of f of x. As a reminder, that is going to be a vertical stretch. So it's stretched vertically. In other words, it's going to get like 4 times as tall as it was. If A is in between 0 and 1, for example, if you had a fraction out in front, or like a decimal, like 0.3, then your graph is going to be compressed vertically. So it's going to get half as tall or 30% as tall. If A is negative, for instance, if you had a negative out in front, the graph is going to be reflected over your x-axis. That's your flip. The h is going to be inside with the x if h is positive. So for example here, if you have f of x plus some number, your graph is going to be moved left. So plus means it's going to be left. That's the opposite type thing. If h is negative, for instance, it's x minus some number inside the parentheses, your graph is going to be moved right. For your k values are going to be moving your graph up and down. So if your k value is positive, so f of x plus some number, the graph is moved up. If k is negative, meaning you have f of x minus some number, the graph is moved down. So that's how your graph is moved all about with these linear transformations. So now what we're going to do is we're going to move away from shapes and we're going to go to lines instead. So we're going to connect it to what we've done in the past. We're going to graph this line f of x. This form f of x equals mx plus b is in slope-intercept form. So my slope is negative 2/3 and my y-intercept is 5. So I'm going to go up to 5 and I'm going to put my point, and then I'm going to go down 2 and right 3 from there. I'm going to graph a couple points that way, and then I'm also going to extend it in the other direction. And then you can draw your straight line here, and you can even call this f of x. The point we're going to be looking at specifically is going to be the y-intercept. So everything from now on is going to look at that y-intercept. That's going to be the point we use to move all around. So we are at 0, 5. Looking at that y-intercept, we're going to draw a new function based off of the transformations that you see below. So just g of x is just telling us, okay, take and graph a new function. If your new function takes the old function and it moves it left 3 and down 6. So we're going to move this graph left 3 and down 6. And we're going to do that based off of our y-intercept. So let's go ahead and take this point and go left 3 and down 6 from there and graph that new point. Then our slope for this one is not changing. So from this point, we now can extend our slope of down 2 and over 3. Or what you can do is you can take another point and move it left 3 and down 6, and you get your new points to graph. And you can keep that pattern up to graph our new function here. We want to call this equation g of x, because g of x moved f of x left 3 and down 6. So to write the equation of g of x, we're going to take a look at our graph. We can see our slope has not changed. It's negative 2/3. But our y-intercept is different. Our new y-intercept is down here at negative 3. So this would be the equation of g of x. Let's go ahead and try another one of these. So we're going to graph our original function based off of our slope-intercept form. So our y-intercept is negative 3. My slope is up 1, right 2, or down 1 and left 2. I can go ahead and connect that line here, and I can call this f of x. The point we're going to be using is going to be the y-intercept here. So we're going to identify the y-intercept, and we're going to do our transformations with that point. Now the transformations we're looking at here have this 2 as your a value. So that is going to be a vertical stretch of 2, which means the height or the distance from the x-axis is going to be multiplied by 2. Let's go ahead and visualize what that looks like. So right now here I went down 3 from 0, 0, like it has a height of negative 3. So if we take that and we multiply it by 2, my new height here has to take that point and go down 6. So my new y-intercept is going to be down here at negative 6. It's stretched by a factor of 2. Let's go ahead and do that for another point here. So the next one here has a height of 2. When I double that height or that distance, it's going to be down here at 4 instead. My next one had a height of 1. I'm going to double that, and my height here is going to be 2 instead. This next point is interesting. 6 comma 0, my height is 0, so it doesn't change at all. How about 8 here? My 8 comma 1 has a height of 1, so my height here has to double, and my new point is going to be twice as tall. My next one also should be twice as tall, and so we can connect these for our new function and call this, oops, it's not f of x anymore, rather it is g of x. So to write my new equation, g of x has a different slope. It goes up 1 over 1 to get to the next point, or up 2 over 2. It reduces to 1. And my y-intercept here, pulling it off the graph, is negative 6. Let's go ahead and try another one here. So let's graph our original function. My y-intercept is 1. My slope is negative 2. So down 2, right 1. You can go ahead and connect that line and call it f of x. Now g of x is going to do two things. It's going to reflect over the x-axis, so it's going to be flipped over, and it's going to be moved left 3. So I'm going to do the left 3 first. So we're going to take all of our points and move them left 3. And then after you move your points left 3, we're going to have to take these points and flip them over. So if you wanted to kind of visualize this line first, this is not my final line, but it is moved left 3 so far. Because now I want to do the reflection. So if I'm going to reflect this over, I'm going to start with my y-intercept down here. Right now I'm going down 5, so I need to flip that over up here and go up 5 instead. So this point got moved all the way up here. I can pick any other point and I can say this one here was moved down 3, so I'm going to flip it up and it's going to be up 3 instead. The next one here was down 1. I'm going to flip it up and it's going to be up 1 instead. And now this one here is up 1, but it's going to get reflected down and it's going to go down 1 instead. And you can at this point notice this pattern here, your slope here, it's constant. So I can now extend my points with a pattern using that slope, and then you can just double check that the points then did get flipped over. This new one here, this is our g of x. So g of x, looking at this now, has a positive slope because it's going up 2 over 1, and my y-intercept is up here at 5. I just pulled those straight off the graph to make my equation. We're going to do another example here. Given these two different equations, we're going to take f of x and we're going to write the equation in slope-intercept form. So I can identify two nice points. I go up 3 over 4, so my slope is 3/4 x, and then my y-intercept is negative 2. This was the equation of g of x. Then I want to figure out how did I get from f of x to g of x. So I can take the point that is graphed here and compare it to the point that is graphed there. So what happened is I moved up 2 and then 1, 2, 3, 4 left. So we're going up 2 and left 4. So in words, that is what is happening. We want to be able to write this using our transformation. So let's go ahead and look at 5b. We want to be able to write it like this. So this says g of x equals, so we're going to start the same way, g of x equals, and what we want to do is we want to take f of x and figure out how it's moved. Since it's moved up 2, we're going to write plus 2 at the end. Since it was left 4, we can show x plus 4 inside. Remember, you do the opposite there. So g of x took f of x and moved it left 4 and up 2. So thank you very much for listening. I hope this helped. Feel free to contact me with any questions you have on anything.